Okay, section 9.2, extra examples number 5 and 6. Number 5, is it better to be last? So on shows like American Idol, contestants often wonder, is there an advantage to performing last? To investigate this, a random sample of 600 American Idol fans is selected, and they are shown the audition tapes of 12 never-before-seen contestants. For each fan, the order of the 12 videos is randomly determined. Thus, if the order of performance doesn't matter, we would expect approximately 1/12 of the fans to prefer the last contestant they view. In this study, 59 of the 600 fans preferred the last contestant they viewed. So that's your sample proportion. And does this data provide convincing evidence that there is an advantage to going last? So what you want to write on your paper, but if this wasn't given, this is what you would assume is you're going to test at alpha equals 0.05 significance level, because if you're asked if the data provides evidence, you need a significance level. So test at alpha equals 0.05 significance level. So we're going to do I'm going to move this, we'll do our state plan, do conclude. So our state is, I like to state the parameter of interest first this way. So let P equal the true proportion of American Idol fans who prefer the last performance they see. So P is the true proportion. So we know what P stands for when we use it in the hypotheses. So let P equal true proportion of fans who prefer last performance. Okay, and now this is still a part of stating the hypotheses. So H naught would be that the proportion is equal to 1/12. And then the alternative, which we want to prove, if we can say that H naught is false, is that the proportion is greater than 1/12. So that would mean that the last performer is preferred, so greater than 1/12. That would be your null hypothesis, H naught and H sub A. So there's our state, our plan. We're going to use, this is called a one sample. I'll state it this time and then I won't in the next one. Use one sample z-test for proportions. Z-test for proportions P if we have to do our R and I if random, and we know the data is from a random sample. Normal, the normal condition, so number of successes and failures have to be greater than or equal to 10. So in this context, so we say N P naught. P naught is the proportion stated in the null hypothesis. That's what the symbol P naught means. So it's number in our sample 600. The proportion is 1/12. So that would be 50. So that's greater than or equal to 10. So we're fine. And N1 minus P naught would be 600 times 1 minus 12. Which is 550, which is greater than or equal to 10. So that's fine. And independent, which means we would assume we're not told how many American Idol fans there are actually, but we would just assume that there are greater than 10 times 600 or 6,000. There's at least 6,000 fans, American Idol fans. So those are our conditions. And then we're going to do, so first you calculate the sample proportion. So that's p hat is going to be, well, what would p hat be? The proportion of fans in the sample. What would it be? (59/600), which is 0.098. So that's the proportion that we found in the sample that we took that preferred the last performer. So we want to know how far off that is from what is stated in the null hypothesis. We want to know how far off our sample was. So you compute what's called the test statistic, and the formula will go in your notes at the end. Test statistic Z, and that would be 0.098, which is what we got in our sample proportion, minus the proportion stated in the null hypothesis. If it's true, it's 0.083 is the same as 1/12 over the standard deviation, because that's how we compute z-scores, but it's the standard deviation of the sample. The formula is p 1 minus p over n, so 0.083 times 1 minus p over the sample size n of 600. So the test statistic z is equal to 1.33, and since okay, so that's the first part, compute the test statistic. Then we can now find our p-value. And remember, the p-value is what we're comparing to alpha to see if we can reject h0. We want our p-value to be less than alpha. So p-value is the probability that z would actually be greater than 1.33, because remember, we choose the direction that our null hypothesis states. It states the probability greater than 1/12. So we want the probability, it's just a one-sided test, that z is greater than 1.33. You already know how to do this, it's great review. So you could look in the table, or you could say normal CDF and use 1.33 to some number to infinity, a big number, and you would get 0.0918. So that means that if h0 is true, there's about a 9% chance of us getting what we did in our sample. So, and that's, 9% is greater than 5%. It could still happen. So we fail to reject the null hypothesis, because 10% that could happen. So the conclusion here is that since the p-value is greater than alpha, we fail to reject h0. So there's not convincing evidence that there's an advantage to performing last. So you have to put it in context. There is not convincing evidence. There is an advantage to performing last. Okay, and then next example is based